Sine waves occur often in physics, signal processing, music, electrical engineering, and many other fields. You've heard of the term sound waves because sound vibrates and makes waves. Of course, waves are in the ocean. Electrical engineering, electrical waves. So anything that oscillates, especially things that oscillate very quickly, can use trig functions to mathematically describe them. The height of water in a wave pool oscillates between a maximum of 13 feet and a minimum of 5 feet. The wave generator pumps 6 waves per minute. Write a sine function that represents the height of the water at time t seconds, and then graph the function. Okay, so let's first talk about the minimum and maximum, what's going on there. So since it has a minimum of 5 feet, and a maximum of 13 feet, that means that the middle between the minimum and the maximum is 9 feet. And we can figure that out by taking 13 plus 5 and dividing that by 2 equals 9 feet. So if that's the midpoint between the highest point of the waves and the lowest point of the waves, that's actually the midline. So we could say the midline is going to be located at y equals 9. And if the midline is located at y equals 9, that means that this graph will have a vertical shift of 9 units up. So that's one thing that's important. Second thing is we need to know about the horizontal shift, if there's any horizontal shift. And I don't believe it shows that there isn't any type of horizontal shift on this one, so we don't have to worry about a phase shift. If we are writing an equation, we do need to have an A value and a B value. The A value is going to be the amplitude. The amplitude, remember, is defined by half the difference from the highest and the lowest points. So half the difference of the highest and the lowest points, again, this is for the amplitude, is going to be 13 minus 5 divided by 2. That's 8 over 2, which equals 4. So the amplitude is going to be 4. We have our vertical shift. We need a B value now. We're supposed to write this in terms of seconds. So we need a period. The period, if it is 6 waves per minute, 60 seconds in a minute, the period is going to be the 60 seconds divided by the 6 waves per minute, which means we have a period of 10 seconds. Now, normally we find period, if we do it in terms of pi, is found by taking either 360 or in terms of pi, 2 pi divided by b. We don't know what b is to write our equation, so we are going to need to find b. So we're going to take the 10-second period that we just figured out and set that equal to 2 pi divided by b and solve for b. I would solve this for b by multiplying both sides by b. So that would give me 10b equals 2 pi. These would have canceled. And then divide by 10. So the b value is 1/5 pi, or just pi over 5. So I have an a value, I have a b value. That means I can write my sine equation. So the equation of this is going to be y equals, my a value was 4. It says use it as sine graph, so 4 sine. My b value was pi over 5, so that would be pi over 5 times t. We're doing this in terms of times, not in terms of theta, so pi over 5t. And then I needed my shift, and my shift was up 9 units, so plus 9. So this is the equation of the graph that I'm going to graph. Now, having said all that, we actually already know a lot of the important parts to figure out this graph. We already know it's a sine function. We know that the midline got shifted up 9 units, so the way I have it scaled up 9 units would be right here. And we already know the period is 6 seconds. So if I graph the unshifted graph with a period of 6 seconds and an amplitude of 4, it would look like this. So it would start here. Over 6 would be slightly past the 5 and up 4. If the period is 6 seconds, this is where it's going to end, I should say. Then halfway between that would be the also at the graph, so halfway between 0 and 6 is 3. So that would be about right here, slightly past that axis. And then halfway between the points would be the high point and the low point. So it does look very small and oscillating very quickly, but this is the unshifted graph. But now we're going to move all of that up 9 units. So every one of these gets moved up 9 units. So this first point is just up 9 units. There was no horizontal shift. And the next point at 4 gets moved up 9 units to 13. Should place it right in the middle of that grid square. And then up 9 units puts it on the midline. The fourth point up 9 units puts it at 5, which is about the middle of that grid square. And then the 6 gets the point at 6, 0 gets moved up 9 units right here. So here is one full cycle. And we can continue to do that as many times as we would like. So if I wanted to do a second cycle, it's at 6. So that means that it will end at 12, which places about right here. So put a point right there on the midline. High point will be halfway between those two. Low point halfway between those two. Here's a second cycle. So the waves of this wave pool are moving very rapidly, and that is the graph that describes it.